welcome back to section 3.2. We're continuing with the law of cosines. This story problem here talks about cities on a map, so let's kind of draw a diagram here. Minneapolis is 165 millimeters due west of Albany. So if I say that this is Albany, and 165 miles due west would be Minneapolis. And then Phoenix is 216 millimeters from Minneapolis. Well, what I know geographically is that Phoenix should be over here somewhere. I'm looking at the map of the United States. That distance then is 368 millimeters, and that's Phoenix. And the distance between, no, that distance is 216, sorry. Distance between here and here, between Phoenix and Albany, is 368. Okay, so I've got my map. The question says find the bearing of Minneapolis from Phoenix. In other words, I want to know if I'm going from Phoenix, what would the bearing be to get to Minneapolis? In other words, if I think about north, south, east, west lines, I'm really looking to find this angle right here, from Phoenix to Minneapolis. I'm going to go through and put some more northwest, east, northeast, south, and west lines on here. I already know that this line right here is an east-west line because it tells me right here that it's due west. And then adding another north-south, east-west line would look like that. The reason I'm going to do this is this is going to set up some parallel lines for me, which is going to set up some congruent angles for me if we remember back from geometry. Again, my goal is to find this angle outside of the triangle. Probably going to be difficult to find the angle outside of the triangle if I don't know the angles inside of the triangle. So here's my game plan. If I know this angle here, and I know the angle outside of the triangle here, I can find the angle here, because this should be 90 degrees. So what I want to do is I want to find angle P, which if we really want to label these with A, B's, and C's, so we can use the law of cosines, we'll keep that as A, we'll change that to B, and we'll make this as C. So then this would be side C, side B, and side A. So if I want to find angle C, if I know that angle, then I need to know the angle outside of here, which will happen to be will be exactly the same as angle A. Here's why. Alternate exterior angles. Actually, this would be alternate interior angles from geometry. This angle here would be exactly the same as this angle here because of the fact of I've got some parallel lines. So if I find angle A, then I know this angle outside. So those are my two things I need to find to be able to then take those angles, subtract them from 90 to find the angle I really want, which is this angle outside of the triangle. Alright, so finding angle C first. Using the law of cosines, we would say that I'm using this, C squared equals A squared plus B squared minus 2AB cosine of C. So 165 squared equals 216 squared plus 368 squared minus 2 times A, which is 216 times 368 times the cosine of C, which is what I don't know. Alright, so algebraically when I start to solve this, I can figure out what this is here. And this is going to give me 27,225. I can figure out what these two are together, and typing that in the calculator, I'm going to get 216 squared plus 368 squared, 182,080. And then taking negative 2 times 216 times 368, I get 158,976, and then times the cosine of C. So I'm going to move this over by subtracting it. Again, I can't subtract these two together because of the cosine of C at the end. end up with negative 154,855 equals negative 158,976 cosine of C. Divide by this. And I get 0.97407 equal to the cosine of C. But I don't really want the cosine of C. Remember, I just want what angle C is, so I move the cosine over by taking the inverse, and I end up with 13.1 equal to angle C. So this angle inside of the triangle is 13.1 degrees. Now we're going to find angle A, so that we actually know this angle outside of the triangle here to help us find this angle over here, which is really what we're looking for as our final answer. So, finding angle A now, we would use this formula where A is on the outside here, and we're finding cosine of A. So A squared would be 216 squared equals B squared plus C squared minus 2 times B times C cosine of A. Again, when we go to solve this, we want to solve this by figuring out what 216 squared is. We can figure out these two together. 368 squared plus 165 squared gives me 162,649. And then negative 2 times 368 times 165. Again, don't make the mistake where you try to subtract these two. You've got to move this over first, the negative, or by subtracting 162,649. And I get this, negative 115,993 equals negative 121,440 times the cosine of A. So now we divide by this. We get 0.9551, and it keeps going on, and that's the cosine of A. Again, I want to just figure out what A is, so I take the cosine inverse, and I would get angle A then to be 17.2. So angle A is 17.2. Again, by geometry, parallel lines and congruent angles, we would know that this would be 17.2 also. Again, my question asks, though, for the bearing from Minneapolis, the bearing of Minneapolis from Phoenix, in other words, going from Phoenix to Minneapolis. So I know that a bearing is a directional distance, so my directional distance would be from this north line heading over here in the east direction. So my answer is going to be north some angle east. And that angle would be 90 minus 13.1 minus 17.2, which is 59.7. So this angle here is 59.7 degrees.